Hello, welcome to today's lesson. We are going to talk about calculus, and calculus was discovered by great mathematicians, which is Isaac Newton and Gottfried Leibniz. Isaac Newton discovered differentiation, and Gottfried discovered integration. This is just by the way. Calculus, there are three areas that you need to know. One, limits. Two, derivative. Three, integration. So you are going to treat them one after the other. Let's talk about limits. Limit helps you to evaluate a function. Let's say given a function f of x and the values of x to be 3. If I substitute in the values of x equals 3 into the function and the function gives me undefined, then limit comes into play. Okay, for more understanding, let's solve more questions. Let's say given a function f of x to be equal to x squared minus 9 divided by x minus 3. Let's say x equals 3. Okay, so substituting x equals 3 or x into the function f of x. So we are going to get 3 squared minus 9 divided by 3 minus 3. Okay, so we are going to get 3 squared is 9 minus 9 divided by 3 minus 3. So this one we are going to get 0 divided by 0, and this is undefined or indeterminate. So here we are going to use limits to get the values of f of x when x equals 3. So let's move on. Okay, so let's take a values of x which is closer to 3. So values of x which are closer to 3, we have 3.1, I can say 3.1 or 3.01. That's the values of x which are closer to 3. Okay, so putting, let's say when x equals 3.1, so we are going to get the function f of x equals 3.1 squared minus 9 divided by 3.1 minus 3. So we are going to get, with the help of the calculator, let me punch it. So 3.1 squared minus 9 divided by 3.1 minus 3. So our answer is 6.1. Okay, when x equals 3.01, let's check f of x. F of x equals 3.01 squared minus 9, all divided by 3.01 minus 3. Okay, so 3.01 squared minus 9 divided by 3.01 minus 3. So we are going to get we are going to get 6.01. Okay, so let's find the limit of the function f of x equals x squared minus 9 divided by x minus 3. Okay, so lim, that's the limit, as x approaches 3 of the function x squared minus 9 divided by x minus 3. So this one we are going to simplify the expression here, because when you substitute in the values of x, we are going to get 0, which is undefined. So per limit, we are going to simplify this by using method of computing difference of two squared. So we are going to get x minus 3, since this is 3 squared, x plus 3, all divided by x minus 3. So x minus 3 will cancel x minus 3, left with, we are going to introduce your limb as x approaches 3. So we are going to get limb as x approaches 3. X minus 3 will cancel x minus 3, left with x plus 3. So our answer, we are going to get, substituting x in this equation, we are going to get 3 plus 3, which is equal to 6. So that's the limit of the function f of x. So you could see that as x approaches 3, we are able to get 6. So x equals 3.1, and it is closer to 3, the value of 3. So we're able to get f of x to be 6.1. The second one, as x was 3.01, we're able to get 6.01. So this means that as x approaches 3, when you take the values of x, which is equal to 3.001, you are going to get closer to what? 6. So that's the function f of x, value of f of x, which is 6. Okay, we are moving to derivative. Okay, so derivative of a function, or let's say derivative, gives you a function of the slope of some values of x. Okay, let's say we have a function f of x. Then the derivative of f of x can be written as d over dx of f of x, which is equal to dy over dx, and it is also equal to derivative of a function, which is f superscript 1 of x. Okay, so this will tell me the slope of the function f of x. So this represents the slope of a function f of x. So dy dx, which is the derivative of the function f of x, gives the slope of a tangent of a line. Okay, so this is very useful for calculating the rate of change. Let's move on. So derivative of a function is given by the formula n multiplying x raised to the power n minus 1. Let's take example. Given f of x equals 2x squared plus 4x. When we take the derivative of the function f of x per the formula, we are going to get dy over dx, which is also equal to, so the power will go and multiply the constant, the coefficient of x squared. So we are going to get 2 times 2x exponent 2 minus 1 plus 4. So we are going to get 4 times 1. That's the power of x times 1 x raised to the power 1 minus 1. So we are going to get 4x plus 4x exponent 0. Okay, plus 4. Any number raised to the power 0 will give as 1 except 0. So 0 squared, 0 raised to the power 0, you are going to get 0. Sorry. 0 exponent 0 is undefined, rather. Undefined. So our final answer is 4x plus 4. Okay, so this function gives us the slope of the function f of x. Okay, so it's the same as the tangent, the slope of the tangent of a line. Okay, let's talk about tangent of a line. Let's say we have a curve. A line that touches the curve at one point is called the tangent. Okay, so tangent of a line, that's the gradient of a tangent of a line, is equal to dy over dx, which is the slope of the function. So assuming we have a point here, so this is our tangent, which is derivative of f of x. Okay, so a line that touches a curve at 2 points is called secant of a line. Secant of a line. Okay, so the gradient of secant is equal to change in y over change in x. This slope, we are familiar with it. That's change in y, which is we have y2 minus y1 all over x2 minus x1 when given values of x and values of y. Let's say we have a point which has a value of 2, another point 7, 3. When they ask you to calculate for the gradient, that's the gradient or slope of a secant, we are going to get, this is our x1, x2, y2, x1, x2. So we are going to get y2 minus y1, which is 3 minus y1, which is 2, all divided by x2, which is 7, minus x1, which is 2. So we are going to get 1 out of 5. So this is the slope or the gradient of this point. Okay, let's talk about the tangent. Given f of x equals s exponent 4. Okay, so dy over dx, which is equal to derivative of f of x, which is f prime, will be equal to, we've discussed earlier, we are going to get 4x raised to the power 3. Okay, so this becomes our gradient of the line, or the gradient of the tangent of the line. So this is the line. Okay. Okay, so we can also use the gradient of the secant. We can find the gradient of a secant to get our slope of the tangent. Let's take a values of x. So let's take this point to be 2. This point to be 2. So here we can use our gradient of the secant to get our slope of the tangent. Okay, so let's take values of x, which is closer to 2. So let's say we have 1.9. 1.9 is closer to 2. We have 2.1, which is also closer to 2. Let's find the gradient of secant of this line. Okay, so we are going to get at this place. Okay, so finding the derivative of f of x, that's the gradient or the slope of the tangent of this line. Okay, so let's say x is equal to 3. That's x approaches 3. We are going to get 4 into bracket 3 exponent 3. Sorry, yeah. So we are going to get 4 times. So our answer is 108. Okay, so we are going to take the values of x, which is closer to 2, using the gradient or finding the gradient of the secant. Okay, so let's move on. So when x is equal to 1 point, sorry, let's say 2.9, then our f of x is equal to, given f of x is given to be x exponent 4. So we substitute in 2.9 in the equation. So we are going to get 2.9 all squared, sorry, exponent 4. So we are going to get 2.9 exponent 4. So we are going to get 70.7281. When x equals 3.1, f of x, we all know f of x, which is equal to y, will be 3.1 exponent 4. 3.1 exponent 4. We're going to get 92.3521. Okay, let's move on. Okay, so let's solve for the gradient of the secant. So gradient of the secant is equal to y2 minus y1 divided by x2 minus x1. So y2, we have our x1, x2, we have y2, then this is f of x is the same as y, so we have y to be 1. Okay, so this can be written as f of 3.1 minus f of 2.9 all divided by x squared minus, sorry, x2 minus x1. Okay, let's move on. So f of 3.1, we know that it is 70.7281 minus f of 2.9. Sorry, there's a mistake here. F of 3.1, which is y2, is 92.352. minus f of 2.9, which is 70.7281, divided by x2, and our x2 is 3.1, x1, which is 2.9. Okay, so we take the values of x, which is closer to 2, closer to 3 rather, closer to 3, to verify the slope at a point 3. Okay, so here this is supposed to be 2.9 and this is 3.1, because our slope here, finding the derivative of f of x, we said the derivative of f of x is the slope of the tangent of this line. So we can also use the gradient of secant to get our values of the tangent of this slope. Okay, so that's what we are doing. So this one, let me get the values. 92.352 minus 70.7281 divided by 3.1 minus 2.9. So we are going to get 108.1195, which is approximately 108. So the gradient of the secant here correspond to the derivative of a function. So this is the gradient of the tangent, which is at x equals 3. Okay, so this graph tells you that when x approaches 3, we are going to get exactly the gradient at that point. So we take the values of x which are closer to 3, we are going to get a slope which is equal to 3. Okay, so let's talk about integration. Integration is the opposite of differentiation. It is also called anti-differentiation. Okay, so that's integration. Integration of a function is given by integration of a function which is f of x is given by integral of f of x dx is given by x raised to the power n plus 1 divided by that power, which is n plus 1. So that's the formula for integration. Let's solve question. Okay, so example, given f of x equals 3x exponent 3. So when you want to find the integral of this function, then we are going to get integral of 3x cubed dx, which is equal to x raised to the power 3x raised to the power 3 plus 1, all divided by the power, which is 3 plus 1 plus the constant. We all know that integration is the opposite of differentiation, and differentiation of a constant is 0. So you need to bring your constant. Okay, so we are going to get 3x raised to the power 4 divided by 4 plus the constant. Integration, it is useful for calculating how much something accumulates at a time. Okay, so let's move on. Okay, so this is we are going to summarize everything. Let's talk about the differences, derivative, then integration. So integration, if you have a curve, the derivative of a function tells us the slope or the function of a slope tangent of a line. At some point, there are some values of x, and it is calculated, it calculates the instantaneous rate of change of that's instantaneous, calculate the instantaneous rate of change. Okay, let's talk about the integration, graph of integration. Let's say we have a curve. We know that the integration calculates how much something accumulates over a period of time. Okay, so let's say that's the graph for integration. The integration talks about the area under a curve, and the derivative is the slope. Talks about the functions of slope of tangents of a line. Okay, so this is our x and this is our y. In derivative, we calculate the slope, which is we divide the y by x. That's change in y over change in x. In integration, we mostly find an area, which is we multiply the x by y. So that's the area. Okay, let's solve small questions. Find the limit derivative and integration of the function f of x equals s cubed plus s squared plus 10. So assuming, let's say, limit as x approaches 2, so we are going to get lim as x approaches 2 of this function s cubed plus s squared plus 10. So we are going to get You just substitute in the values of x. So we are going to get 2 exponent 3 plus 2 exponent 2 plus 10. So we are going to get 8 plus 4 plus 10, which is equal to 22. Okay, so let's find the derivative of f of x. So derivative of f of x, which is f prime of x, which is equal to dy over dx, is equal to, so per the formula, this will come and multiply this. So you're going to get 3x exponent 3, then you subtract 1, plus 2x exponent 2 minus 1. We all know that the derivative of, or dy dx of a constant is 0. Why? Because the x over here is raised to the power 0, and x raised to the power 0 is 1. So this one will come and multiply the coefficient of x, making it 0. So the derivative of a constant is 0. Okay, so we are going to get 3x exponent 2 plus 2x. Okay, let's find the integration or integral of f of x. So we are going to get s cubed plus s squared plus 10 dx, which is equal to, so per the formula, we are going to get x raised to the power 3 plus 1. Then we divide the exponent. We divide the expression by the exponent, 3 plus 1. So we are going to get x exponent 2 plus 1 divided by 2 plus 1 plus, so this has x power 1, x power 0, sorry. So we are going to get 10 x raised to the power 0 plus 1 divided by 0 plus 1. Then we introduce our constant. Okay, so we are going to get x raised to the power 4 divided by 4 plus x raised to the power 3 divided by 3 plus 10x. So 0 plus 1, which is 1, plus c. So okay, so this is the end of the section.